All right, let's just jump right in. You've probably heard the pitch for the monorepo, right? This idea of having one single unified home for all of a company's code. It's sold as this dream of simplicity, of easy collaboration, but as anyone who's lived it knows, as your teams and your code base start to grow, that dream can turn into a real nightmare. We're talking slow builds, developer frustration, it's a mess. So today, we're going to dig into this hidden crisis of monorepos at scale, and more importantly, the brilliant tools that are finally solving it. I just love this quote because it hits the nail on the head. It perfectly captures that feeling, doesn't it? You've got this massive, powerful thing, this cruise ship of a code base, but the second you try to do something simple, like make a small change, it becomes this incredibly slow, painful, and ridiculously complicated operation. For way too many developers, this is their daily reality. It's what I call CI hell. So how in the world did we get here? How does this great promise of a streamlined, unified codebase just curdle into a massive bottleneck for an entire engineering organization? Let's break down where the dream falls apart. Okay, so at its core, this is really a choice between two big philosophies. You've got the polyrepo, where every little project or service gets its own separate repository. The problem there, you often end up in what's known as dependency hell, a total mess of versioning conflicts. And then you have the monorepo, which promises to fix all that with a single source of truth. It makes big, sweeping changes and sharing code seem totally effortless. And honestly, that is a very appealing promise. But here's the trap. That promise? It actually holds up, at first. But then you add more projects, more developers, and your basic, naive tools just can't keep up. They see one tiny change in one corner of the codebase, and they just panic. They assume the absolute worst-case scenario and decide to rebuild and retest every single thing in the entire repository, just in case. And suddenly, the very system that was supposed to create speed becomes the anchor weighing everyone down. And I want to be clear, this is not some theoretical problem. This number, 45 minutes, this is from a real company we'll call Startup X. That was their average wait time for the CI pipeline to say yes or no on a single tiny change. Now imagine that, times 50 developers every single day. That's not just a delay, that's a massive, soul-crushing drain on productivity and morale. But here's the secret, and it's a good one. This problem was actually solved a long time ago. The solution was forged inside the very tech giants who were the first to crash into this wall of complexity at a massive scale. And for years, they had a secret weapon. Yeah, this idea is not new at all. It was literally born out of pure necessity. It all started way back in 2006 with Google's internal tool, a thing called Blaze. Then came Facebook with Buck, and Twitter with Pants. Look, these weren't just simple build scripts. This was a completely new way of thinking about how you build software. It was a massive paradigm shift. Now, the core scientific principle that makes all this incredible speed possible is something called the hermetic build. The best way to think about it is like a perfectly sealed laboratory experiment. The whole process is completely isolated from the outside world. It gives you a rock-solid guarantee that if you put in the exact same set of inputs, the source code, the dependencies, the config files, you will get the exact same output every single time. And that guarantee, well, that's what unlocked the real game changer. Right, so this isn't magic, not at all. It's just a really clever application of computer science principles to eliminate redundant, wasted work. So let's pop the hood and see how these modern tools actually achieve their incredible speed. It really boils down to this elegant, four-step process. First, the tool has to build a deep understanding of your entire codebase. Then it creates a unique fingerprint for every single piece of work it might need to do. After that, it just checks its memory to see if it's done that exact job before. And finally, and this is the key, it only executes what is absolutely 100% necessary. So, step 1, the tool acts like a detective. And I mean a serious one. It doesn't just glance at your package.json files. No, it performs a deep static analysis of your source code. It traces every single import and require statement. It builds this incredibly precise map of your entire repository, kind of like a detective's corkboard with yarn connecting every single clue. This graph, this is the brain of the whole operation. Now for that fingerprint. What makes it so powerful is everything that goes into it. It's not just your source files. It's the versions of your dependencies, the tool's own configuration, and, this is super clever, even the fingerprints of all the other tasks that this task depends on. It means if a single grain of salt changes anywhere in that chain, the entire fingerprint changes. It's perfect. And the payoff for creating that perfect fingerprint is just immense. The tool checks its cache, think of it as its perfect, unforgettable memory, and if it finds a match for that fingerprint, it just skips the expensive work of rebuilding or retesting and pulls the results straight from storage. Now, this works on your local machine, which is great, but the real power comes from a shared remote cache, where work done by your coworker or the CI server can be instantly reused by every single developer on the team. It's a total game changer.
For years, this kind of power was basically locked away inside those tech giants. But now, a new wave of open source tools has come along and democratized this FANG-scale infrastructure for everybody. And that's led to a bit of a showdown between the two major players who have packaged these principles up for the modern JavaScript and TypeScript world. And that brings us to the two big names you'll hear about, Nux and Turborepo. Choosing between them really comes down to a core trade-off. Think of Nux as the batteries-included toolkit. It's incredibly powerful, it's adaptable to a bunch of different languages, but it definitely has a steeper learning curve. It gives you stuff like code generators, visual dependency graphs, and really deep integrations with popular frameworks. Turborepo, on the other hand, is just laser-focused on one thing, dead simple speed. The setup is minimal, so it's crazy fast to adopt, especially if you're already in a JavaScript project or using Vercel. Now, this difference in philosophy even shows up in performance. While Turbo is fast, one benchmark showed Nux being over 7 times faster on a really large project. Why? Well, because of its more advanced task orchestration and analysis. So you're basically choosing between power and extensibility versus pure, focused speed.
Okay, so the theory is fantastic, right? But what really matters is the real-world impact. Let's look at the absolutely dramatic transformation these tools have had on actual development teams. Let's go back to our friends at Startup X. Remember this number? 45 minutes. This was the crippling wait time that just defined their daily lives. That's 45 minutes of waiting, of switching tasks, of totally lost productivity. Just brutal. And this is the after. By adopting one of these modern tools and flipping on remote caching, they slashed their pipeline time all the way down to just 4 minutes. That is an order of magnitude improvement. It's not just an optimization, it's a complete fundamental transformation of how they work. Honestly, this is my favorite piece of feedback from that whole case study. It's the ultimate validation, you know? This technology didn't just improve some metric on a dashboard. It removed a massive source of daily frustration and fundamentally improved the quality of life for the people building the product. And this impact is not an isolated incident. Just look at these other numbers. A critical project over at Bloomberg saw a 65% improvement in developer productivity. Another open source project managed to cut its release process time by a staggering 75%. The evidence is just crystal clear. When you stop wasting time on work that's already been done, the gains are absolutely immense. But ultimately, this is about so much more than just speed. It creates what's called a virtuous cycle, or a flywheel effect. See, faster builds lead to faster feedback. That encourages developers to make smaller, more frequent commits. That leads to more deployments, which gets new features to users faster, which then generates more user feedback. And the entire innovation flywheel of the company just starts spinning faster and faster. Which really leaves us with one final question to think about. I want you to consider your own team, your own projects. Is your development flywheel spinning faster every day? Is it accelerating, or does it feel like you're trying to parallel park that cruise ship every single day? The tools to break free from that feeling are here, and they are more accessible than they have ever been before.